Okay, so as Matthew said, my name's John Turner. I'm a development manager at Paddy Power. The team that I manage, they tend to do their own thing, but the team that I manage is a team that's focused on building continuous delivery and platform as a service for Paddy Power. So what I'm going to talk about is a bit of a timeline and some of the interesting things that have occurred along that timeline over the last 2 years whilst we've been doing this at Paddy Power. So, as I said, I work in Paddy Power. Predominantly my background is not operations, so it's development. So, from a continuous delivery and PaaS point of view, that would be a strong bias from my perspective, but we also have people within the team who are strongly biased towards operations, and hopefully that way we get some sort of balance in terms of people's passions in the team. I've been using continuous integration since 2003, since cruise control was in its heyday. And it seems obligatory if you're doing some of these talks to have written some books, right? And I haven't written any books, but I decided that I'd share with you some of the books I'd like to have written if I was an author. So, if you're interested in implementing continuous delivery and platform as a service, I tend not to distinguish the two things, even though I appreciate that they're very different. For the most part, why you're interested in this is to optimize for speed, and that was certainly the case at Paddy Power. So about 2 years ago, we looked at the major re-architecture of one of our back office systems, and one of the non-functional requirements for that development effort was that we reduce the cycle time and increase the throughput of features to production. And that's what led us to look at continuous delivery, also at DevOps, and specifically what Netflix were doing with DevOps, and obviously the Adrian Cockcroft no-ops famous comment then influenced us to start implementing platform as a service. So the reason why we want to optimize for speed, we want to beat our competitors, right? We don't want to be lunch. We want to grow our own market and grow our share of the market. So we want to be able to bring more product to market, implement hypothesis-driven development techniques, so test the market with different products really quickly and really cheaply, and in essence, innovate faster than any of our competitors. I think there are a few people from Betfair here today, so I hope you go easy on me. So how did we do that? Or how did we feel we could do that best? So we wanted to try and streamline the decision-making process. And for the most part, what that meant was introducing convention where we could. So removing decisions in their entirety and falling back on convention. We wanted to build better, faster, and lighter. And so for us, what that meant, better meant that we would focus our entire development model and technology stack on quality. So we introduced BDD and a very strong focus on quality assurance, as you'll see when we have a look at the pipeline that we implemented a little bit later on. We wanted to build faster. So as I said, that means reorientating the organization to support the engineering team, removing decisions, removing cross-team or cross-boundary interactions where possible and replacing those with APIs. And we also wanted to build lighter. So we were making decisions a lot quicker. We wanted to be able to change our minds when we got those decisions wrong. So we wanted the systems that we built to be more adaptable. We wanted to be able to replace technologies if we made poor technology choices. We wanted to be able to evolve architectures where we made poor architectural choices. But you want to do that safely, right? And so there are a few things that come into play. So obviously quality is the biggest thing when you want to move quickly, safely. And so part of the initiative that we undertook was to have our engineers own quality. And from a cultural perspective, that was quite a big shift. But interestingly, it was one that was adopted quite readily. You write it, you run it, so everybody knows this. in the DevOps space, so our developers now support our production systems. And that avoids moral hazard. So that avoids the situation where I build poor quality code and I hand it off to somebody else who has to get up in the middle of the night to support it. Optimizing for speed safely also meant implementing continuous delivery. One of the things that tripped us up early on when we were trying to sell this concept was not distinguishing between the desire to do continuous delivery and continuous deployment. A lot of the organization misunderstood what we were trying to achieve, and they felt that it was too dangerous for us to automatically push code directly from our Git repository into production. And so very quickly we had to clarify that misunderstanding, in that continuous delivery requires manual promotion, and for us it requires manual promotion from the automated test phase into a manual test phase and into production. Everything's still fully automated, but it just requires human intervention. And as I said earlier on, that continuous delivery pipeline is built on a convention. So for every application that we've built since the introduction of this pipeline, it uses exactly the same life cycle, exactly the same stages, and exactly the same transitions. And we also looked at changing the characteristics of system complexity. So as I said, we were looking at re-architecting one of the major back office systems, and that had evolved over a period of about 5 years, and it had become quite complex. It was very monolithic in nature, and we wanted to try and address that complexity. But it was important, I guess, to establish that we weren't trying to remove the complexity, because you can't remove complexity from an inherently complex system. We were trying to change the characteristics of that complexity. So we were deliberately distributing those services, and rather than the complexity being any one of those individual services, the complexity is now in the way that those services have different life cycles from one another and the way they interact with one another. And the way we propose managing that complexity is via PaaS. So PaaS provides orchestration around release cycles, around management in production, around the type of implicit tooling that gets deployed with your systems to provide runtime visibility, and that manages the complexity of that distributed architecture. So I'll just go through stage delivery pipeline. I really hope this is not too boring for everybody and you aren't as well versed in this stuff as I suspect you may be. But this is in fact a fair reflection of the delivery pipeline that we employ at Paddy Power, or more accurately within certain groups in Paddy Power. So as I said, generically a stage delivery pipeline looks like this, and we spent about 8 weeks at the start of this initiative agreeing with the development teams what this needs to look like, and that's now been adopted across all of the development teams. So we have a number of different stages and transitions between those. Sometimes they're automatic and sometimes they're manual, and within each stage we have a life cycle. Not particularly interesting, but this is probably a close reflection of the types of stages that we employ at Paddy Power. So the first two are what you would consider fairly traditional continuous integration steps. In fact, the only reason why they're separate from one another is because we found that the development teams wanted quicker feedback on the code commit stage, so we separated some of those activities. You can see the rest of the pipeline is predominantly focused on quality assurance. So acceptance tests, performance tests, stability in manual, and then production. And I'll go into some of those stages in a bit more detail.
Silly question.
Yeah.
Are those arrows different colours?
Yes. Sorry. Yes. So basically the green arrows mean that if there's success at one stage, they promote automatically. So we promote automatically up to the end of the stability test phase, and then from then on there's manual tests that occur. Or sorry, manual transitions that occur.
Sorry, one more silly question. Are those promotions on schedule or every commit?
No. Oh, they're on every commit. Yeah, yeah. So the code commit stage, I'll just go through the stage lifecycle. So we use Git. So checkout means basically check out the Git repo locally. We then apply a version locally. We branch, which is a Git branch, if you like. That's a local branch. So we employ fully trunk-based development. So all our development teams use feature toggles and branch by abstraction in order to hide features that aren't ready for release. And we release the entirety of trunk every time we release. So there's dormant code within every single release. And what this avoids is the complexities around feature branching and code merges. Because what we had before were development teams with a tendency to have long-lived feature branches, and that caused us a lot of pain. All of our test phases, as per this unit test, have a setup and teardown stage, and this is pretty standard. Check out the code, perform a build, do some unit tests, notify the next stage or notify whomever in the event of failure. Typically we manage the whomever via crowd, so via Active Directory user groups, and that allows the development teams themselves to manage who gets notifications, who has authority to do these types of promotions and whatnot. So they manage all that authentication themselves. And as said, the build stage and the code commit stage are effectively the continuous integration part of the pipeline. So again, we check out the local repo because the workspace is not necessarily on the same machine anymore. We perform a build again, unit tests, and here we perform some integration tests. So not system integration tests, but component integration tests. So all of those integration tests are performed on a hermetic server, so on a single server with no network interfaces between the components. And that gives us a really quick feedback on the component integration and how well that's working. We publish a set of reports and we execute a set of quality rules, and typically that's based on Sonar. At this point now we have an artifact that we think that may be potentially releasable. We install that artifact into a potential release candidate in a repository in Artifactory, and then we progress to the next stage. So this is the first stage during which we set up an environment. So within Git, there obviously exists the source code, some configuration, and other files that are required to build the application. But also within Git exists what we call the application blueprint. So the application blueprint describes the set of services upon which an application depends. So an example of a service might be the base image that it requires, so the OS if you like, the language runtime, so Java or Ruby or .NET or whatever it might be, the application container, the database, the message broker, and all the dependencies between all of those things. So that constitutes the application blueprint, and together with the application blueprint, the source code, and the configuration management repository, it allows our platform to deploy that application into an environment. So when we've done that, every time we execute an environment provisioning step, we execute a set of smoke tests. So obviously the smoke test has to be non-destructive and all that sort of stuff, so that we can execute the same smoke tests in every single environment, including production. We then execute acceptance tests. What's interesting here is that we implemented BDD. We use Thucydides predominantly and JBehave. And when a product owner specifies a feature, they have to specify the acceptance criteria for that feature. If they don't specify the acceptance criteria, then they don't get the feature. So they only get what they've specified as an acceptance criteria. They specify that in given, when, then format. And that's traceable right through the development process. So a developer takes a card off the board. First thing they do is they write the acceptance test. and they tag that acceptance test as pending. So it's not started development. And whenever we produce these reports, a report is generated that's accessible to the product owner that says, here's something that's with a developer now, but he hasn't started development on it. Whenever he begins development on the acceptance test, he changed the tag on the test, and now the next time the report runs, you can see that it's in progress. When he starts developing the feature, the test is failing to begin with. The product owner can now see that the feature is in development but not yet complete. And whenever it's complete, the tests are passing and they can see that the feature is now complete. We publish a set of reports in relation to all of those tests, and we tear down the environment. So typically that just means destroying the VMs, and we progress to the next stage, which is the performance test stage. So again, we create a brand new environment. The environment that we create is not necessarily indicative of the environment in production. And so we're not trying to generate a measure of absolute performance for that system or those services. What we're trying to generate is a trending indicator for the performance of that service or system. So since the last time it has built, has the performance degraded in any significant way? And if it has, then we can trigger a build failure and push that back to the developer. So in order to make that in any way useful, what we also have to do on a regular basis is baseline that trend. So typically what's possible is either to execute a separate and distinct performance test, or you can baseline in production as well. So if I push a release 1.2, for example, through this process, I have a certain trend for performance of each of the services or functions within that application, and I can marry that to a baseline that we've generated from version 1.2 in production. We had a hack day last year, and one of the guys decided that he would re-implement Netflix Simian Army, and not the whole thing, certain portions of the Simian Army. And so what the Simian Army does is it introduces failure to the application, and it introduces failure into the application during acceptance test run. So the continuous delivery pipeline will deploy the application. It will execute a suite of acceptance tests, and during that execution it will introduce failure. So that failure might be disable a NIC, fork bomb a machine, or shut down a machine entirely, depending on what was specified in the application blueprint. If all is good and there is a set of features that are valuable and to the product owner, and they wish to release those features potentially to production, typically what happens is we have a manual test phase. So you're probably wondering, if we do all this testing, why we bother? And I guess I'm not sure if there's a good answer. Some of it is around having a warm fuzzy feeling. Some of it is around some of it is because there are features that are either difficult or expensive to test in an automated way, and some of it might be because of compliance. So depending in the environment in which you're operating, certain releases may require legal culpability for the feature set that you're releasing. So in that case, whomever is culpable for that set of features wants to actually see them before they go out the door. And I'm not going to say too much about production, but similarly, production lifecycle is very similar to the others, with the exception that typically production rollout occurs over a set of environment segments as opposed to a single environment. I mean, there's not much distinction really between an environment segment and an environment. The only distinction basically is the traffic source is the same across all of those segments, and the orchestration has to manage the routing of that traffic across the segments as you're rolling out new features. That's the continuous delivery pipeline. The The stages in the life cycle that I discussed there, they're all considered to be abstract. And whenever we're implementing a continuous delivery pipeline for one of the development teams, we don't have to force upon them specific build tools or anything like that. What we tend to do is bind that lifecycle to those build tools. So, for example, if it's rake, we will specify a convention whereby that lifecycle matches to a number of rake tasks. Or if it's Maven, we'll have a custom Maven POM that implements those lifecycle stages. Whenever we started looking at this, I was told to change this the font before this presentation, but I didn't get a chance. But this is the Gartner maturity curve, and whenever we started looking at this, SaaS-based platform as a service was actually quite mature. Like Heroku and Engine Yard and PaaS like that were generally pretty well adopted in certain spaces within the industry, and those organizations were typically getting good value out of using PaaS. But within the enterprise, we were much further to the left-hand side. There was, and there still is today, huge fragmentation in this space. And it made it very difficult for us to decide what path we would take in terms of selecting a specific platform that we would leverage. What it came down to a couple of things in the end. We wanted a platform that was very open. So we didn't want a platform that enforced a specific deployment model. So we didn't want to introduce containers, for example, into an organization that didn't leverage containers, be they Docker or anything else. There are other PaaSes that have their own concepts of containers, and OpenShift has gears and all these sorts of things. We didn't want to introduce that because we felt that would be an additional barrier to rolling this out across the organization. And if we use the VM as the actual container, we felt that people would have they would feel a lot more familiar with managing and operating applications that were deployed onto a VM as opposed to into specific containers. And similarly with configuration management tooling, we didn't want a PaaS that was very opinionated in terms of the type of configuration management or monitoring tooling that we leveraged. So for example, some PaaSes would mandate that traffic route through their own virtual routers and things like this. And that's something that we didn't want to enforce as part of our tool selection. So we ended up selecting a tool called Cloudify from a company called Gigaspaces. And effectively, we use a quite narrow range of the functionality that PaaS provides. And the range of functionality that we leverage is the specification of application services, of application blueprints, and the orchestration of provisioning those. Yeah. So this is what we ended up looking like after a period of time. We have a set of infrastructure services, a set of PaaS services. So we could see things coming into this PaaS space like database as a service, messaging as a service, etc., etc. So we explicitly defined these and then ignored them for a period of time to allow us to focus on what we considered application services and application platform. And our application teams started to look like this. They were fully autonomous. They managed applications cradle to grave, and they were fully responsible for those applications, including all of the quality, the tool selection. You may consider that the way we bind to build tools, for example, to be quite loose. But we had a fine line to tread in terms of being too opinionated ourselves. So we didn't want to mandate that certain build tools or certain testing frameworks or even certain language runtimes, for that matter, were utilized within the platform. So we wanted to give that flexibility to the application teams themselves. Whenever I was sort of looking back on this a few months ago, was thinking of a way that I could communicate all of the things that had to come together for us to be successful in a single diagram. And I can't remember who did this first, but I stole this off Google. Well, not the actual diagram, but the idea. So I took this idea of putting together this tube map. And again, when I was showing this to somebody last week, they said, don't show that at a presentation. There's just too much crap on that board. The people will fall asleep. But it's valuable in some respects because there is so much crap on the board. There is so much going on around continuous delivery and PaaS that you have to consider if you want to be successful. We'll briefly look at each of these train lines. So, yeah, as you can see, I have separated the train lines, and the circles are concepts, right? It's fairly straightforward. A large portion of this page is taken up by quality assurance concepts. I explained a little bit about how we did performance testing and failure testing and acceptance testing earlier on. Interestingly, whenever we started doing manual, or whenever we introduced manual testing into the pipeline, development teams insisted there was a system test phase and the UAT test phase. What tended to happen over a period of time was that the teams started to use only one of those environments because the quality that was coming out from the pipeline to the system test stage was of such a standard that it could be put directly in front of the product owner without any sort of manual oversight from their perspective. So they were happy to fold both of those manual test environments into one. And of course, that means for us like less hardware, less tin, less processing and all that sort of stuff. So that's good. The other big concept, of course, is IaaS. So the difficulty here is that traditionally organizations don't have this capability. So you don't have a capability to orchestrate your infrastructure to the extent that's required if you're doing automated deployments and provisioning. So there's a lot of new ground to break. So storage and compute and virtualization are all relatively straightforward, but things like networking, typically over a period of time, enterprises develop an extraordinarily complex network topology, and if you're trying to perform automated deployments into that network, especially where there's physical devices existing that aren't API enabled, then that becomes very complex. You either have to try and simplify the network, which is my preference, or you have to try and orchestrate all of that complexity. The point that we got to in that space is effectively just managing service groups within either physical or virtual load balancers. And we use the load balancer then in the same way that Netflix use ELB as a single entry point into all of their service groups. We use the load balancer as a single entry point into all of our service groups. So platform as a service substantially consists of a number of things, being configuration management, and in our case we use Chef. I guess, yeah, there's loads of people who spend a long time having debates around which configuration management tooling to adopt, and for us, way back when, the discussion was around Chef and Puppet, and to be honest, thinking back, I think it was a fairly arbitrary decision. I think the main reason why we chose to use Chef is because of the bias of developers on the team who were very comfortable developing a Ruby DSL and not so comfortable with the declarative nature of Puppet, or the majority of Puppet's use cases are declarative based, even though you can use it, their DSL as well. These two concepts, the application service and the blueprint, are concepts that we adopted from Cloudify, who is the PaaS vendor. As I said earlier on, an application service can be anything from a language runtime to a database or a broker. But effectively, the application service is a building block for the blueprint, which allows you to declaratively describe your application topology. What was also very important for us when we were thinking about PaaS was the ability to provide implicit value. So there are certain things that had frustrated us as development team over the years, and no surprise, log aggregation and log analytics in a distributed environment was one of those things. So based on following a number of conventions, we made the availability of those services implicit within the PaaS. So if you deploy a piece of software to the PaaS, automatically it will have log aggregation and log analytics as a service. And we also spent quite a long period of time looking at APM. Because we see PaaS as an enabler for DevOps, we wanted to build in DevOps tooling into our platform. And APM was able to provide us implicit insight into the runtime behavior of our applications. Specifically, we were interested in that behavior in a distributed environment. So we purchased a product called AppDynamics. And what AppDynamics does is, when we deploy, say for example, Java, it deploys a Java agent that instruments the code base, and it intuitively understands network hops. So it understands the libraries that invoke network hops within your application. So HTTP libraries or JMS libraries or whatever. And it enriches the payload of those messages with a coordination ID. And it uploads that into a controller. And as that payload hops across different nodes, it uploads all of that information and correlates it on the controller to provide a distributed graph of that business transaction. So for example, a login that hits 5 servers, for example, normally what you end up doing is doing some sort of log chase across all of those 5 servers. But with something like AppDynamics or with distributed transaction traceability, you get that for free. So you get a really nice visual that represents all of the network hops, the latencies, the throughputs, the error rates. And it also provides features like automated baselining. So if anybody has been involved in setting alert thresholds and whatnot on systems, it's extremely difficult, right? And what AppDynamics does is it automatically learns the behavior of the system during normal operation, and it automatically tries to set those baselines based on normal operation. I'm not a salesperson for AppDynamics, by the way. But I can get commission, so if anybody wants to submit an order, that's good. And then finally, there's lots of different types of orchestration that occur. There's orchestration of the build itself. There's orchestration of the deployment pipeline and the provisioning of the application. But there's also post-provisioning orchestration like auto-scaling or recovery. So I'll leave that behind, and I'll talk about some of those concepts more specifically. One of the other decisions that we had to consider was to what extent would we bake or fry our machine images. This guy is called Fry. I did a Google search for a funny image with Fry in it. He came up. Apparently he's popular. But to what extent would we bake or fry, right? So Netflix really famously have this concept of a bakery. It's a Netflix OSS framework that they have available on GitHub. And what it does is it bakes all of the application configuration into an AMI, and it allows them to provision a VM from that AMI, and the application is ready to run. It's ready to accept traffic. So it's really, really quick in scenarios where you need to auto-scale, you have large service groups, really beneficial. It's only possible to do that, however, when you're provisioning all of your environments from scratch and you're not doing any post-provisioning convergence. So we don't have that luxury. So we have environments where we can't provision infrastructure on demand. And so in those environments, we have static infrastructure. And where we have static infrastructure, we have to do post-provisioning configuration, right? So we provision the application version 1, and we have to provision version 2 on top of version 1. So we can't bake our AMIs, if you like. And so in terms of the spectrum of bake or fry, we tend more to frying our machine images. So our machine image contains just enough OS, and on top of that we layer the majority of the software stack every time it's required. Now, this is quite slow. It's much, much slower than provisioning a machine image that's already fully baked. But unfortunately, it's a necessary evil when you have static infrastructure. So just a quick word on configuration management. So Chef and Puppet, etc., are desired state configuration tools, right? Which means that you specify the desired state of whatever it is you're configuring. You execute a convergence run, and the configuration management software then converges the current state to the desired state. And that's great. And we use, as I said, Chef for this, and Puppet's cool too. The difficulty is, though, that most of the time you can't just execute desired state configuration tooling across your entire estate and hope for the best and everything will work, because often there's orchestration that's required on top of that. So I have to release this piece first before I release this piece or this piece. I guess a database is a great example, which we don't do, but it's the only example I could think of. But you get the point. So there are certain services that need to be deployed before certain other services can be deployed or converged. And so there's orchestration required on top of that desired state configuration tooling. Yeah, and this is just basically to highlight the term application service, again, which we took from Gigaspace's. Application service can be, it's a very generic term, it can be any of these things. Here's a look at an application blueprint or an application topology. I don't know, does anybody know Pet Clinic, the Spring application? We use Pet Clinic to prove a lot of this stuff. Our Pet Clinic's a little bit different because it uses Cassandra, MySQL, and Rabbit, and it uses every technology you can think of. But it proves that we can deploy all of these application services together. But here's an example. So within that application blueprint, you'll define a Cassandra cluster. In this instance, we've defined a cluster with 3 nodes. You can actually define auto-scaling limits. So I want a minimum of 3 nodes and a maximum of 5 nodes. I want to trigger an auto-scaling event if the query response time exceeds 10 milliseconds or whatever it might be. We've also defined a Tomcat cluster here. And so it has 3 nodes as well. But interestingly, it depends on Cassandra. So it's down to the orchestration of the provisioning of this software to deploy the Cassandra cluster first, deploy the Tomcat cluster. And in a Java environment, what we do is we create a JNDI lookup for a Cassandra connection factory, and the application then looks up that JNDI resource and automatically has a connection to the Cassandra cluster, even though it doesn't know where it is. So the provisioning process took care of the discovery of the Cassandra cluster. And a similar thing happens with the load balancer. We actually do this both ways, depending on the type of load balancer that we're using. When the Tomcat instance comes up, it contacts the load balancer and adds itself into a specific service group that's specified within the application blueprint. Or it can occur the other way, where we bring up, specifically if we're using software load balancers, we bring up the load balancer first. We define the service group, and then we add the Tomcat instances into that service group. But often, for the majority of cases, we use static load balancers. So either VPX or hardware based. And all of that gets a little bit more complex whenever you're looking at environment orchestration. So it's all very well to provision an application once and to bind all those services together, but if you have in a single environment 5 different applications, and all of those applications have a separate and distinct release cycles from one another, so we can provision them all together in one go, and that's grand because we can orchestrate the order of those things, and we can make sure that the green square comes up before the black square comes up, and that's all good. But whenever the green square wants to release version 1.2, what happens? The black square has to be notified that an update of the green square service is going to occur, and if its location has changed, it has to be notified that the location has changed. So a good example of the way companies are doing this is something like Airbnb's Smart Stack, which effectively uses client-side load balancing for this sort of technique. Is everybody kind of with me still? Talking too quick? No? Good. Okay. Okay. And as I said, one of the key things as part of the platform was that we exposed services implicitly. Here's an example of what I'm talking about with the application topology view with AppDynamics. So this is automatically discovered. So every time I do an application release, I don't have to hand over a load of documentation to my operations team, if we have an operations team, in order to try and redraw this topology, because it's discovered at runtime and it's accurate, unlike most documentation. So nearly finished. 2 quotes to finish up. This speaks to the nature of how we started doing all of this stuff. So as I said, we were looking at the re-architecture of one of our major systems, and we wanted to start looking at PaaS, but we didn't want to go through the whole rigmarole, I guess, of engaging with this unorthodox system. And so we went a little bit undercover, and we have high-powered desktops. All of our developers have 12-core crazy spec desktops, and we took some of them and we virtualized them with KVM, and we put CloudStack in front of it, and we built all of this stuff on top of that infrastructure. And I guess what that allowed us to do is this become prevalent before we had to take on the burden of orthodox organizations and all the process and whatnot that goes around that. And most of then, whenever you try and step out of that sort of stealth mode type approach, you start to come across more challenges that are not necessarily technically based. So they're based on the org itself. So with any large enterprise, I think we have over 300 people in IT. So with any large enterprise, it's natural that different clans evolve and establish around technologies, around functions or whatever. And when you're trying to employ or deploy something as disruptive as continuous delivery and PaaS, it's going to affect all of those people. And that becomes the major challenge when you're trying to roll something like that out across the organization. So that's it. Hopefully that was useful.